Okay, so in this first question, um, there is something called columns, which are drawn on the floor. So first of all, there will be dots which are drawn, and around them you have to draw lines. Now these lines come in something called loops. So a loop is when you start from a specific spot, you go around dots, and then in the end you end at the same spot. And the loop has to have at least one dot inside it for it to be considered a loop. So here you can see that one loop is this. I just do it in a different color. One loop is this. Another one is this right here. All of the triangles and this diamond in the middle. So those are the loops. The question is, which of these options has the fewest loops?
Did everybody understand the question?
Yes.
Okay, before I start solving it, is there anyone who would like to solve it for us first? Okay, I guess I'll solve it. So let's look at this option by option. So we have this first option right here. Um, let's start drawing the loops so we know how many loops there are. All of the loops in the first option are the same shape. So you can see this here is one loop. I'll just zoom in a bit. Yeah. This is one loop. Then another loop is this one. All the loops are starting and ending at the same place. Another loop is this one. And another loop is this one. So we've covered all the lines. And in total, we've seen four loops here. Next, we look at this one. We can see there's one big loop here, like in the example they've shown above. That's one loop. And then there's these four other loops. So this is one. And then the same loop is repeated again right here, here, and here. So this has five loops in total. Then let's go to the next option. We can see here there's one loop. This one big loop is there, which goes around the whole thing, right? Started here, ended here. And then we have these two bar legs, one and another one, right? So we have three loops in this. And if we look at the last question, in this question, we actually have, let's try tracing this. It's a bit lengthy, but if we keep tracing this, eventually we will only have one loop. This entire thing is one loop. Even these get traced out. And this has only one loop. So option D has the fewest loops. Does anybody have a doubt or anyone who didn't understand anything? Okay, I guess we can go to the next question then. So in this question, there's two people. One person is one person is Monica and one person is Veronica. Both of them have a necklace for each of them. Here are the two necklaces they've shown. They each take turns checking which is there on the right of their necklace. And then, depending on some circumstances, they add it to the left of either their own necklace or the other person's necklace. So here it says if the pearl is yellow or red, which is square and triangle, they add it to the left of the other's necklace, right? And if the square is any other color, that is green circle or blue star, they add it to the left of their own necklace. Monica always goes first, and then Veronica. And we have to find out how it will look after each of them has given three necklaces, three pearls to the other person, right? So we have to we have to do it till each has given three pearls to the other, and then once we've done that, we will know which option is correct. Yeah, I'll wait for another minute so you can. Okay. Before I do it, would anybody like to attempt the question here? Okay, I'll do it. So let's start from Monica, of course. And yeah, let's start from Monica. We know that the yellow color squares, obviously, they go to the left of the other person's necklace. So on the first turn, this square goes from here to here, right? Then we know that Monica has given one pearl to the other person. We have to do it till both of them have given three to the other person. Next comes Veronica. Veronica has a red triangle, and we know that red triangles are also given to the other person. So a red triangle goes here. Next has a yellow square. Again, we know that yellow squares are given to the other person. So a yellow square goes here. And that means Monica is given two things. Next, it's Veronica's turn. A blue star. Now we know that anything except a red triangle and a yellow circle goes to yourself. So a blue star will go back to herself. And one second. And Veronica has given one this red triangle. Now it's Monica's turn again. Monica has this circle right here. We know that circles do not go to the other person. So circle go to yourself as well. And now Veronica has another red triangle. Now we know that red triangles go to the other person. So red triangle goes here. And now both of them have given two things to the other. It's Monica's turn again. And green circle. Green circle goes to yourself right here. Veronica's turn. A blue star. Blue star also goes to herself again. Next, we have a yellow square, which is nice. Yellow square will go to the other person. So Veronica gets a yellow square. And now Monica has given three things. And next is a red star on Veronica's side, which is also given to the other person. And now we know that both of them have given three things each to the other person. So in the end, this and this is how their necklaces should look. We just have to find the option. And if we look at option one, we can see that let's look at the rest so that we can just cancel them out. So we need the Monica's to be triangle, circle, triangle, circle, triangle. This is circle, triangle, circle, not triangle, circle, triangle. So this is wrong. Triangle, circle, triangle, square. Now we have triangle, circle, triangle, circle, not square. So this is wrong as well. Triangle, circle, triangle, and this is triangle, triangle, circle. So wrong as well. So we know that the right answer is option A. And yes, this sum is done as well. Let's move on to this one. I'll read it out. So there are two kinds of machines in the stone factory. When we put an arrangement of stones into these machines from left hand side, remove some stones and put out a specific arrangement of stones on the right. So whatever's on the left is your input, whatever's on the right is your output. The blue machine is called an odd machine. So this is called an odd machine, which puts out stones in the odd places and removes every second stone, right? It basically means the output is every second stone. So we know that the first stone won't be the output because it's an odd place. So every even place stones from the input is the output. So we know that there's the second stone, so it's the output. Third will be cancelled. Fourth stone, which is even again, then the output, and so on till the end. So all these stones are there in the output, whichever ones have not cancelled, right? Then comes the brown machine with a number n on it. It's called a trim machine. It removes the first and last stones and puts out whichever stones that are left. The picture below shows a trim machine with the number 3 on it. So this means that this is the input side. And from the input, it will remove the first and last n stones. N is whatever numbers here. So it will remove the first and last three stones. So one, two, three, one, two, three. So this is what remains, which is on the output side. These two machines can be combined, and the output of the first machine will be the input of the second machine, right? So whatever is the output, so when we are solving this question, whatever is the output from here then goes into here. So now we have to find out what the output in the end looks like. So try solving this for this machine right here and find out which option is right. I'll wait for another minute. Okay, a minute is up. Is there who would like to solve the question before I do?
Can I solve it?
Yeah, sure, go ahead.
Okay. So, according to the instructions that are given, there are two machines: the odd machine and the and the trim machine. So, the odd machine will take out all the odd stones, starting from the second stone. So it will take out the stones that are not cut. So these are all the stones from second, starting from the second stone, that the odd machine will take out. The second machine shows that it will take out the number of stones given on it from both sides of the stones. So since the number given here is 2, it will cut two stones each on the edges. So the answer that will be remaining will be B.
Okay, thank you, Arnav. Um, in case anyone has a doubt, I'll just summarize this up once again. So what Arnav said was, just give me a second. Yeah, Arnav said that first the odd stones will not be there, right? These stones will not be there. And then what Arnav said was, the first two and the last two stones will also be removed by the second machine. So the only stones remaining are this one, this one, this one, this one. Are these stones. So Arnav got the right answer, which was B. Okay. Okay, I think this one is a slightly harder, at least it says over here. Why? Um, just give me a second. Yeah. So in a castle called Mysteria, there lives a single wizard. This wizard can turn themselves into a fairy, so this one, into a fairy, or create a fairy beside them to the right. So a wizard becomes a wizard and a fairy to the right. The fairy can turn into a potion on the left and a dragon on the right. So the fairy can turn into this, a potion on the left and a dragon on the right. Or the fairy can also turn 2, a potion on the left, a wizard in the middle, and a dragon on the right, or a wizard in the center and a dragon on the right, is shown by the following table. The contents of Mysteria, yeah, so these are the only four transformations that are there. You can't go backwards transformations, you can only go forwards. So now your question is, starting with a single wizard, which of these Mysteria states are not possible to obtain? So I'll just write it here so you can just see the options. Single wizard. Yeah. So you start with a single wizard. Which of these four options are not possible to obtain? Not possible. Go ahead. Yeah, wait. Let me just also show you the transformation so that you have a reference. I'll wait for one last minute. Okay. Um, bef- Before I solve the question, is there anyone who would like to solve it for us? Okay, I'll solve it. So for this question, we have to work backwards. So we start by looking at the options and we have to convert them backwards in our heads and see if it matches and ends up in a single wizard. One thing to remember is that a fairy does not turn into a wizard, which uh, you might make this mistake sometimes because it's just single ones, but fairy does not become a wizard. Okay. Let's start with the option that's the shortest and move up. So this one's the shortest. It's a potion, a dragon, a potion, and if we look right here, a fairy turns into a potion and a dragon. And we have to work backwards, right? So we can say that this potion and a dragon was initially a fairy, and this potion and a dragon was initially another fairy. So we have two fairies now, and we need to make two fairies into a wizard. So we see that if we get a fairy and a wizard, we can work backwards and get a wizard. And to get this wizard, we can just make one of our fairies working backwards a wizard. So let's just say that this fairy was actually a wizard before it turned into a fairy. So now we have, sorry, I wrote a, that's not a potion, that is a wizard. So now we have a wizard and a fairy, and we know that a wizard and a fairy, we can work backwards, and that is just a wizard. So we know that option D is not the right option because obviously we are meeting the condition, which is of one wizard. We need to find the option where we cannot have one wizard. So option D is wrong. The next shortest one is this one up here, option A. Let's go for it. Starts with a potion, wizard, potion, dragon, dragon. Now we see that there's a dragon and a potion right here. We know that a dragon and a potion can come from a fairy. So let's turn this dragon and potion into a fairy. So now we have potion, wizard, fairy, dragon, right? Now we just look for what else we can convert. Now we see we have a wizard and a fairy, right? A wizard and a fairy. We can work backwards and turn a wizard and a fairy into a wizard. So this wizard and fairy is just a wizard. So we have potion, wizard, and dragon. And potion, wizard, and dragon is just a fairy again. Potion, wizard, and dragon is just a fairy again. And we know that a fairy working backwards is actually a wizard. So we end up with a single wizard again. Hence, option A cannot be the right answer. It meets the condition. One more thing to keep in mind is that the order matters a lot. So a potion wizard dragon, if it's potion dragon wizard, it cannot be a fairy. This order has to be the same for it to be the exact equation. Okay. So then we go for the next shortest option, which is C, where it says we have a fairy, a potion, a dragon, a potion, a wizard, and a dragon. This one is fairly simple. We look at this right side here, three things. Potion, wizard, dragon, which we know is a fairy. So most of this option is already done. Potion, wizard, fairy, sorry, potion, wizard, dragon is actually a fairy. Then we have a potion and a dragon right here. And potion and dragon working backwards is another fairy. So we have three fairies in total after solving the whole thing. And then we know that this fairy is just a wizard. So this becomes a wizard and a fairy and a fairy. And a wizard and a fairy is a wizard. So these two cancel out, become a wizard. This comes down. And fairy. And wizard and fairy again is just a wizard. And so for option C as well, we end up with one wizard. That means we can do it. So option B is the right answer, which is the only one remaining in the end. Yeah. Let's just move on to the next question. Ram has a collection of gems. He ranks his gems from his overall favorite to his least favorite. Sunita knows what gems are in Ram's collection, but she does not know how he has ranked them. Sunita has a plan to find out which gem is Ram's favorite. Okay, so he has some gems in his collection. Okay, he has some gems in his collection. And Sunita wants to find out which is his favorite. Sunita chooses four of Ram's gems and asks him, out of this group of four, which gem is your favorite? So every time she picks four gems, okay? And then Sunita chooses a new set of four gems and asks the question again. So that's two times she's asked it. Then she chooses a third set of four gems and asks her question for the last time, right? So she asked the question three times. So every time there's four gems shown. And they're asking when she chooses her second and third set of four gems, she may have included the gem she has chosen before. So gems can be repeated. Gems can repeat. Question is, if Sunita is to find Ram's overall favorite gem, what is the largest possible number of gems in Ram's collection? Right? So I'll give you all 2 minutes to try this out. Good luck. It's not that hard. I think 1 minute should be enough. Good luck. So would anybody want to solve it? Say you answered it, so would you like to solve it for us? Or even Arnav Gupta, would you like to solve it?
Avinash, you
Oh,
missed a question.
no, I'm just choosing random questions. I'm not going in any order.
No, you missed one. Four tiles was before Mysteria.
Okay, I guess we can go for it. I'll do one more question after this, and then if we have time, we'll go for that one. Arnav Gupta, can, you can go ahead.
Do I have the option to annotate?
Yeah, I think you do. Yeah, you can annotate. You have the permission, right?
Yes. Okay. To annotate, I click view options, right?
Yeah, just hover over it, and I think
No,
at the
I'm currently using that web meeting because my Zoom is updated. I won't be able to annotate.
will you be able to explain it in words if you can't annotate?
Yeah, so basically, first I go with the least amount, that is 8. Reason being, so I'll number 1, 2, 3, 4, 5, 6, 7, 8. I'll keep these numbers on my screen. Then I will take the first 4 pair of gems. I'll make a group of first 4 gems, that is 1, 2, 3, and 4. And I'll ask what's his favorite in that. Then let's say he said 4. Then I will take 4, 6, and 7. Now he can pick any number, that is gem 4, gem 5, gem 6, or gem 7. Now, since let's say he picks gem 5, so I know that gem 5 is more, he likes gem 5 more than gem 4, he likes gem 5 more than gem 6, he likes gem 7, 5 more than gem 7, and the gem 1, 2, and 3. So that way I know that between the first 7 gems, he likes the gem 5. Now, I can do this with the third one also. make sure to include 5. Now I can take gem 5, gem 8, gem 9, and gem 10. That this will be the last question I can ask. So in that, whatever he says is his favorite is the favorite one.
Okay, does anyone have a doubt with what he said? Anything anyone didn't understand? Because this question was easy. I think we'll just move on to the next question since we have only 5 minutes, 4 minutes left. Should we do this one or a harder one? Yes, this one's safe around. We can try this one. Okay, so the Beaver's family lodge consists of 21 canals. 31 stones need to be removed. The beavers go for a swim and collect the stones and bring them to the deposit. Okay, so we know that beavers start here. They swim around these canals, go to the intersections, get stones, and bring them to the deposit right here. Stones are heavy. A beaver can only carry one or two of them at the same time. So maximum capacity for a beaver to carry is two, but no more. To get from one intersection to the following, beavers swim surprisingly always for exactly 1 hour. So let's say this is an intersection from three stones to four stones here. That's 1 hour. But if we go from these three and these two here, like this entire thing, that will also be 1 hour. So distance between any two intersections, no matter what they show in the picture here, is 1 hour, right? Okay. After starting simultaneously, so they all start at the same time, viewers have to collect all stones within 4 hours. So the maximum trip a beaver can, maximum number of trips or canals a beaver can travel is four. How many beavers do we need at least? So I'll just
Not
I'll
the number of
just
canals, that's the number of hours they take, that they're allowed to take to complete.
what? Could you repeat?
Four is not that how many number of stones they have to take. 4 hour, it's 4 hours, which means they have to take that they have to bring all the stones to deposit under 4 hours.
Yeah, you have to bring them under 4 hours, but as they've said, one canal takes 1 hour. So 4 hours will be four canals, right? So did you understand? Like maximum will be four canals traveled because one canal is 1 hour. So 4 hours will be four canals. Yeah, but you're right. So let's say we start at let's see one second. Yeah, let's start over here. We need to see how many stones or like how many beavers we need per place. So first of all, for these two stones, you need one beaver. So this is one beaver. Here we need two beavers. Right? We can just mark it and solve it. So one beaver, two beavers, one beaver here with one stone remaining, right? Then here we can have two beavers again. One beaver with one stone remaining. Here again, one beaver with one stone remaining. One beaver with one stone remaining. Two beavers with one stone remaining. And two beavers. So how many beavers have we used so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 beavers. Right. Okay, so now all we have to do is figure out how we're going to collect the remaining one stones, like this one stone, then this one stone here, this one stone here, this one stone, to figure how we're going to collect all these with the fewest number of beavers. So first, if you notice, let's say two beavers go this way, two beavers go this way, right? They collect these stones, they go here, they deposit them. They've traveled two canals. That means two of their hours are gone. So out of the four, they have two left. So one trip here goes, then they've used three of their hours and comes back. That's the fourth hour. So the same beaver that I sent this way has also collected the stone here. So this stone is out of question. And we did not add any extra beavers. The same beaver did the job, right? Now have um yeah, now we have a few more beavers. So as I said, two beavers get this stone. Wait, just give me a second. Yeah, so let's say we have another beaver. We add another beaver. This beaver goes here, picks up this extra one stone that we have. It goes here, picks up this extra one stone that we have. And then finally, it goes along this whole path. So it goes 1 hour, 2 hour, 3 hours, 4 hours. So we add another beaver to the equation. So this becomes 14 beavers. And then we have two stone.
Manish.
Yeah,
Mm, no, never mind, never mind.
yeah. What happened?
I was thinking that in some intersections, like in some canals, there are only three stones. So one stone is going to waste. Like if a beaver can carry two stones at max, if we find a path in which a beaver is carrying both the stones he can, then it will require less beavers.
We have to send two beavers then in the three areas because one beaver can take two stones and the second beaver can take that one stone.
Wait, remove all this. Just annotate and show me what you're saying. Yeah.
So if you have got three stones, then you should send two beavers. One beaver will collect two of the stones, and the other
Yeah.
beaver will connect one. And then
Yeah.
you can go to another canal and collect one more, and you can send one beaver in the other canal to collect the rest too. So to
Yeah.
complete so to complete two about six stones to get about six stones for a deposit, you will need about three.
Mm-hmm. So you're saying a beaver comes here, takes the stone. Like, let's say two of these stones are already gone. So there's one stone remaining here and one stone remaining here. You're saying a beaver comes here, takes this stone, goes here, takes this stone, and then completes his journey, right? Is that what you're saying?
I'm saying that the two stones out of the three can be taken by one beaver to the deposit,
Yeah.
and from the other three stone pile, another beaver can take two of the stones.
Yeah.
Then you employ a third beaver who will take the one stone left from all the three stones from each of the groups, and then he will take those two stones for a deposit because the maximum amount of stones that one beaver can carry is two.
Yeah. Okay. That's what we did, right? Nice. So we'll just put this into action one last time. So we know that we need one beaver for this, two beavers for this. You've already marked it. Yeah. Okay. And here we will have one stone remaining. So here is where we need a stone. Here is where we need a stone. Here is where we need a stone. Here. Here. And before this, how many beavers had we used? One, two, three, four, five, six, 7, 13, right? And then this one was done by the same beaver that went this way. So now we have 4 stones remaining. No, it's not 14 yet, Arnav, because the same beaver did this job as well. So it's still
Avnish,
13. Yeah.
to find the least amount of beavers, we also have to make sure that no beaver is carrying one stone.
No beaver is carrying what?
No beaver is carrying only one stone.
That's not necessary. I mean, yeah, yeah, that makes sense. But sometimes we need to have that because the other beavers cannot get there in just 4 hours, right?
Okay.
Okay, what we can do is we send one beaver here. He takes the one stone from here. And then we send another beaver here who takes one stone from here. They both come here, take one stone each again, and then they go here. So we cancel this out and we used, I think, the same number of beavers. And then finally, we have a beaver who goes here. This is the extra beaver, right? This extra beaver goes here, takes this one stone. then goes here, takes this one stone, and then goes around in 4 hours. So that is 1, 2, 3, 4. Perfectly 4 hours. And this is the extra beaver. And in the end, we have 14 beavers. So did that make sense at all?
Yes.
Any doubts with this? I
No.
think we spent a decent amount of time on this question. So yeah, and it should be 14 should be our answer. And yeah, the answer is A, 14. Thank you.